Welcome to DepEd TV. I am Teacher Joshua, and I will be your guide in sharpening your skills and enhancing your minds in order to face the challenges here in Grade 8 Mathematics. Ready your self-learning modules, your paper and your pen with you. Let us have a wonderful day of learning. The first lesson that we will tackle is factoring polynomials. Specifically, the greatest common monomial factor. But before that, I would like you to observe the following images. Can you give a description that is common to all of them? They are all orange in color. What else? They are all good for your health. How about this? What is common among these four? Even if they are of different colors, we know that all of these are crayons. What if I ask you to think what is common with 2, 4, and 6? They are all even numbers or divisible by 2. If we look at their factors, 2 has 1 and 2. 4 has 1, 2, and 4. 6 has 1, 2, 3, and 6. Observe that aside from 1, all of them has a factor of 2. How about on these expressions? X, 2x, 3x, and 4x. They all have the same variable, x. Like in English and science, we can also find commonalities in algebra. Specifically, the greatest common factor. It is just what you did in the constants 2, 4, and 6, and the expressions x, 2x, 3x, and 4x. Easy, right? In this lesson, we will factor polynomials with a common monomial factor. Let us start with a review on how to get the greatest common factor. And one way to find the greatest common factor of 2 or more numbers is prime factorization. Let us determine the greatest common factor of 8 and 12. First thing to do is write each number as a product of prime factors. 8 is equal to the product of 2 times 2 times 2, while 12 is equal to 2 times 2 times 3. Do you see the same number in each set of factors? Next is we identify common prime factors of the given numbers. We can show them by encircling the common factors by pairs. Last is to multiply the common factors. So what is the greatest common factor of 8 and 12? The greatest common factor is 4, which is the product of the common factors 2 times 2. How about the greatest common factor of algebraic expressions where there are variables and exponents? Since a variable represents an unknown value, we cannot use prime factorization to find their greatest common factor. So how can we find the GCF of n cubed, n raised to 5, n raised to 6, and n raised to 9? What do you remember about the variable n raised to an exponent? It means that n raised to an exponent k means n is multiplied to itself k times based on the given exponent. So n cubed is n times n times n. Same goes to the expression n raised to 5. It is equivalent to the product of n written 5 times. Also with the other expressions. What did you observe? How many n is common in the factors? The greatest common factor is n cubed, or n raised to 3 from n times n times n. Let us review the following terms. According to the Compact Oxford English Dictionary, the word polynomial comes from the Latin Greek words poly, meaning many, and nomen, which means name or term. Therefore, polynomial means many terms. A polynomial is an algebraic expression that shows a sum or difference of two or more terms containing whole number exponents on the variable. A variable is a symbol which represents an unknown value. A constant is a symbol or a number with fixed value. In an algebraic term, numbers form the numerical coefficient while symbols form the literal coefficient. In this example, the expression is 4x squared minus 2. This is a polynomial since the variables have non-negative whole number exponents. This polynomial has two terms, 4x squared and 2. The first term has a numerical coefficient 4 and a literal coefficient x squared. An exponent refers to the number of times a number is multiplied by itself. The last term is a constant term since there are no variables multiplied to the number. Now, we will determine the greatest common factor of algebraic expressions with numerical and literal coefficients. Find the greatest common factor of 4x cubed and 8x squared. 4x cubed can be expressed as a product of 2 times 2 times x times x times x, and 8x squared is equal to 2 times 2 times 2 times x times x. Next step is we identify common factors. We can separate and align the numerical and literal coefficients to make this easy. Can you identify which is common among the prime factors? How many 2 are common? How many x are common? We can encircle these pairs to help us determine the common factors. The common factors are 2, 2, x, and x. Last is to get the product of these common factors. The product is the greatest common factor of the given 4x cubed and 8x squared. We will multiply 2 times 2 times x times x. The greatest common factor of 4x cubed and 8x squared is 4x squared. Now, let us try this example. Find the greatest common factor of these expressions. 15y raised to the power of 6 and 9z. The first step is to enumerate the prime factors. What is the prime factorization of 15y raised to 6? The numerical coefficient can be factored as 3 times 5, while y raised to 6 means that y is multiplied to itself 6 times. How about 9z? 9z is equal to 3 times 3 times z. Can you identify all common factors? Note that 3 is the only common factor. Hence, the greatest common factor of 15y raised to the power of 6 and 9z is 3. That is one method we can use to determine the greatest common factor of polynomials. But there are some cases where it seems that a given pair of monomials do not have a common factor. Observe these monomials, 4a squared and 9b squared. Let us start with the numerical coefficients 4 and 9. 4 can be expressed as the product 2 times 2, and 9 can be expressed as 3 times 3. Do they have common factors? In a glance, they seem to have no common factors. But remember that 1 is a factor of any number. Hence, the greatest common factors of 4 and 9 is 1. Next, are there any common factors for the literal coefficients, a squared and b squared? Since the expressions do not have common variables, we can conclude that 1 is the greatest common factor of the given monomials. Therefore, the greatest common monomial factor of 4a squared and 9b squared is 1. And if the GCF of the expressions is 1, we can say that they are relatively prime. How about if we get the greatest common factor of three monomials? What is the greatest common factor of 6a squared b squared, 3ab squared, and 15a cubed b squared? First, get their prime factors. 6a squared b squared is equal to 2 times 3 times a times a times b times b. How about 3ab squared? 3ab squared is just 3 times a times b times b. Note that we use two variables here, so it can be helpful to separate them in our solution. Then we have 15a cubed b squared. This monomial can be written as 3 times 5 multiplied with a times a times a multiplied with b times b because of the indicated exponents. Now, identify the common factors. We will have these numbers and variables. And lastly, we write the product of these factors. What would be our final answer? The greatest common factor of the expressions 6a squared b squared, 3ab squared, and 15a cubed b squared is the product 3 times a times b times b, which is 3ab squared. We've exercised our eyes on finding common characteristics of things. And we exercise our minds by reviewing prime factorization and the greatest common factor. We may now proceed on how we can use these skills. Let us have an exercise in getting the greatest common factor of these expressions. Let us start with the greatest common factor of 12a and 18abc. The greatest common factor of 12a and 18abc is 6a. Next, what is the greatest common factor of 4x, 12x squared, and 8? The answer is 4. How about the greatest common factor of 6x, 14y, and 15z? Since all three expressions do not have a common prime factor, we can say that they are relatively prime. Hence, the greatest common factor of 6x, 14y, and 15z is 1. Notice that in the previous examples, prime factorization is used to find the greatest common factor of the given pair of monomials. The next examples illustrate how to factor polynomials by getting the greatest common monomial factor. Let us write the expression 6x plus 3x squared in factored form. We can factor this polynomial by getting the greatest common factor of each term. And I will introduce a new method to acquire the common factors. We can divide the solution into two parts. One for identifying the greatest common factor of the polynomial, and then finding the other factor with the help of the identified expression. 6x plus 3x squared is a binomial. 6x is the first term, and 3x squared is the second term. The numerical coefficient of 6x in the first term is 6, and 3 in the second term. Observe the literal coefficients. The simplest way to identify their greatest common factor is to get the common variables with the least exponent. By prime factorization, we will get a greatest common factor 3x. To factor 6x plus 3x squared, simply divide each term of the given polynomial by the common factor. 6x divided by 3x and 3x squared divided by 3x. By applying division and the quotient rule in the laws of exponent, 6x divided by 3x is equal to 2. 6x divided by x is just 1. Then, what is 3x squared divided by 3x? 3 divided by 3 is 1, and x squared divided by x is just x. Do not forget the signs to complete our polynomial factor. Last step is to write the polynomial in factored form. The polynomial 6x plus 3x squared can be written in factored form as 3x multiplied by the quantity 2 plus x. Remember that getting the greatest common monomial factor is different from writing a polynomial in its factored form. Factoring is often called the reverse process of multiplying polynomials, where we write a polynomial as a product of two or more simpler polynomials. Now, let us try this example. Write 12x cubed y raised to 5 minus 20x raised to 5 y squared z in complete factored form. Again, we can break it down into parts so we can focus on each step while factoring. First, find the greatest common monomial factor. 12 is equal to 2 times 2 times 3, and 20 is equal to 2 times 2 times 5. Then we get the common variables in each term which has the least exponent. So what is the greatest common monomial factor? It is 4x cubed y squared. Then, find the other factor by dividing each term of the polynomial by the greatest common monomial factor. The operation can be shown as such. We divide 12 by 4 and subtract exponents of expressions with similar bases. The first term of the factor will be 3y cubed minus the second term. What do you think will it be? 20 divided by 4 is 5. Then applying the laws of exponents, we will have x squared and z. Since y squared divided by y squared is 1. Step 5. Write the polynomial in factored form. In this example, we have shown that 12x cubed y raised to 5 minus 20x raised to 5 y squared z is equivalent to 4x cubed y squared times the quantity 3y cubed minus 5x squared z. Let us try the next example. Get the factors of 2x plus 3y squared. What is the greatest common factor of 2 and 3? Since these numerical coefficients and constant are relatively prime, the greatest common factor is 1. How about the literal coefficients? They do not have any common variables. Hence, the greatest common factor is also 1. Similar to our previous example in finding the greatest common monomial factor, there will be instances that it is 1. We call these polynomials prime polynomials. And there you have it. We have discussed how to factor polynomials by getting the greatest common monomial factor. Let us have a recap. 1. Factoring is the reverse process of multiplication, where we write a polynomial as a product of two or more simpler polynomials. 2. The greatest common monomial factor of two or more expressions is the product of the GCF of the numerical and literal coefficients. 3. Prime polynomials are polynomials whose greatest common monomial factor is 1 and can only be written as a product of 1 and the polynomial itself. Number 4. To factor a polynomial using its greatest common monomial factor, we can consider these steps. A. Find the greatest common monomial factor of the numerical coefficients. B. Find the variables with the least exponent that appears in each term of the polynomial. It serves as the GCF of the literal coefficients. C. Get the product of the greatest common factor of the numerical coefficient and the variables. The product serves as the greatest common monomial factor of the given polynomial. D. Find the other factor by dividing the given polynomial by its greatest common monomial factor. And E. Write the final factored form of the polynomial. Since we are near the end of your lesson, prepare your pens and your paper because it is important to evaluate what you have learned. I will give you 10 seconds to answer each item. Write a polynomial factor in the blank. Complete each statement. Number 1, 7p squared minus 7p is equal to 7p times the quantity of what polynomial? The answer is p minus 1. Number 2, 18xy plus 3y is equal to blank times the quantity of 6x plus 1. polynomial 18xy plus 3y can be written as the product 3y times the binomial 6x plus 1. Number 3, 15m cubed minus 15m squared plus 20m is equal to 5m times what polynomial? The polynomial factor in this item is 3m squared minus 3m plus 4. Number 4, 17x raised to 5 minus 51x raised to 4 minus 34x in factored form is blank times the quantity of x raised to 4 minus 3x cubed minus 2. The greatest common monomial factor is 17x. Number 5. What is the factor of the polynomial 35x raised to 5y squared plus 21x raised to 4y plus 14x cubed y squared if the greatest common factor is equal to 7x cubed y? The answer is 5x squared y plus 3x plus 2y. How are you in the short seat work? Did you get a high score? Nevertheless, I know you have done a great job. Remember that it is okay to commit mistakes at the start. The important thing is you learn from these mistakes and apply that knowledge to become better in math and in life. As an additional exercise and practice at home, try answering the activity on the Self-Learning Module 1A at page 10, Activity 1, Break the Grade. I hope that you have learned a lot in our episode today. Note that there are many ways to factor polynomials, and you must focus on the key concepts and process in factoring these polynomials. With a little more practice, I believe that you can ace any lesson in mathematics. Next topic will be factoring polynomials that we call special products. Remember, math is not only about numbers and operations. It is an exercise for our minds, for us to be critical, logical, and responsible thinkers. Again, this is Teacher Joshua, reminding you to keep safe, have a nice day, and see you next time.